Hello, my name is Hendrix, and I'll be presenting and demonstrating some queries used to show the expressiveness of my database system. So I'll start by showing the ERD, briefly explaining it. So I have 10 tables, and this system focuses on the properties. A property is posted by what we call a vendor in our system. A vendor is a type of customer to a solicitor. Now a solicitor has two types of customers, the client and the vendor. The vendor is the person who advertises the property. The client is one who advertises, or a client is one who buys the property. And once the property is bought, the property is added to this property sort table, which indicates the details on the selling. Property can be advertised in newspaper, and an estate agent company has several staff members who are assigned to several properties. So I'm going to demonstrate some queries that I used to see how expressiveness my database system. So the first query that I'm going to demonstrate is a query that uses order by. So we use I'm using the database, my SQL database management system. Yeah. So let's switch to that. There it is. So I'm writing this. Select all from solicitors, order by solicitor ID. Now what is happening here is I'm retrieving all data from this solicitors table, and I'm simply ordering by this column here, the solicitor ID. Again, if I wrote another query, almost the same, select all from solicitors, and I decided to order by the solicitor last name, I simply write that here, solicitor last name, and the results are simply ordered by the last name here. That's ascending. By default, it is ascending. And if I wanted them to be descending, I'll simply have to write this. And as you can see, it now starts from the S there, S, P, M, L, and then it's descending. So that's the first query that uses the order by. And now the second query that we're going to see is a query that uses inner joins. Now an inner join is very similar to the normal join that we use, the default joins. So let's get back to the console. I write that, and here it is. I'm selecting from two tables, or rather three tables, customers, properties, and property sort. I'm using this concate function, which simply combines the results of two columns as one. So I'm combining the first name and last name. I just want it to appear in this column as buyer, and I'm also selecting the property name from the property sort table. So the table selected are customers, and I'm using the alias CC. I'm inner joining that to the clients table, and the clients table is inner joining to the properties table, which is also inner joining to the property sort table. So that's basically four tables instead. So all these are using the inner join, and with the inner join, we put the conditions on there. So the property ID in the last table is equal to the property ID in the second from the last table, and the client ID from the client's table is equal to the customer ID from the customer's table. Yeah, so here are the results. We simply have the property name and the person who bought that. So that's from four different tables. Now the next query that we're going to see is a query that uses a subquery in the where clause. Now a subquery is a nested query. Yeah, we're going to see a query that uses a subquery in the where clause. A subquery is a nested query. That's simply a query inside another query, as in a query put inside the main query. So back to the console. I'm gonna write that. Now we're selecting these three columns again. P.clientID, customer first name and last name have been concatenated as client, and number of properties bought from the clients table has been chosen. Now tables as clients using an alias P, and customers using C. So where the customer ID from the customers table is equal to the client ID from the P clients table. Yeah, and the number of properties bought. We're using this subquery. Select max number of properties bought. So that's, yeah, we're selecting the maximum number of properties bought. So we actually want to choose the clients who have the maximum number of properties bought. So that's why we have this subquery here in the where condition here, and this is the result that we get. And from here, the next query that we're going to use is a query that uses partial matching in the where clause. Now, partial matching is equal to the equal sign. Yeah, partial matching is equal to the equal sign that we use in the normal the normal queries. So back to the console. I'm gonna write this. We are selecting all from solicitors where solicitor first name like Claire. Now we have solicitor first name Claire, as in Claire. Since we're just partially matching, we're just gonna write part of the name. Yeah. So when I close this, here it is, solicitor first name. Now this is different from the equal sign because from the equals, it actually wants the full name. So if I write is equal to, then I leave it blank like that, it will not bring me any results because there is no such first name. So that's why we use the partial matching, because we're searching partially. We're trying to match it partially. Yeah, there it is, first name. So the next query that we're going to see is a query that uses aggregate functions. The aggregate function that I'm going to use is the count function. I'm going to be counting the number of properties a client has bought. Yeah, so I'm going to go to the console. I'm going to write this. So now we're selecting the client ID from the client's table. We're again combining these two columns, customer first name, so it appears as one column as client, and they're all coming from the customer table. And we're counting the number of columns in the property sorted table. The number of columns according to the number of client columns, client ID columns. Yeah, from these three tables, the customers CC, and we're left joining the client's table with the property sort table. Yeah, and the results are being grouped by the client ID from the client table. Yeah, so this means every client, the client table, that appears in the client ID table column in the property sort table has a value greater than 0. Otherwise, anything less than 1 is appearing as a 0 in this table here. So that's how the aggregate function count has been used as the count. So the next query that we're going to look at is a query that uses the group by and having clause. So this isn't very different from the example that I just gave right now. It's not at all different. Yeah, a query that uses the group by and having clause. Back to console. I'm gonna write the same query that I wrote here, and I'm simply copy that, copy it from, I don't know, copy, paste. So this is the same group by. Let's just bring an error. Yeah, so there we are. So it's the same query, we just added this column, this row rather, of having count, client ID greater than 0. Now from the first results, we simply wanted to output the clients that have at least one property that has been bought. That's why we're using the having count here. Yeah, so we're grouping by the client ID from the client's table, and then the results are being there's a condition that the results being retrieved should be greater than 0. The count should be greater than 0. So that's about the query that uses a group by and having clause. Because sometimes we just retrieve the clients that have at least a minimum of one property bought. So now we're going to look again on subqueries. We're going to look at a query that uses a subquery as a relation. Now, a relation in the database is simply a table. So we want a subquery to be used as a table. Yeah, as a table for retrieving other values. So I'll write this query here. Now we're selecting customer ID, customer first name, customer last name, from. Now this is where we usually put the table name, but in this case, instead of putting the table name, we're gonna put a subquery. We're gonna put a query inside. We're gonna nest a query inside the main query. So the query we're nesting here is this query here. We're selecting C, which is customers. So we're selecting customer ID from the customers table, customer first name, customer last name from the customers table, and we're also selecting from the clients. Yeah. So and the condition is the client ID has to be equal to the customer ID, which means this is us simply trying to select all the customers who are of the client type. Remember, we have two types of customers. Two types of customers: the vendors and the clients. So we're simply selecting all customers who are clients. Yeah. And after selecting this, after using a subquery as a relation, we always recommend it to give it a name here, because if you don't put this, it'll bring us an error. So if we just write select this from this with that and then close, we usually get every derived table must have its own alias. So that's why we write like the way we wrote at first. Yeah, that's why we actually give it a name here, so that the query finishes. Where is it? That's why we actually give it a name here, so that the query gets to finish. So that's it about a subquery being used as a relation. Now the next query we're going to look is a query that uses a self-join. Now a self-join is when a table is simply retrieving data, it's simply joining with itself. Yeah, and this might be useful in very rare conditions, but yeah, it still has its use in those very rare conditions. So I'm gonna be using the console again, the MySQL console. Let's switch to that, and I write that. Now I'm selecting vendor ID, v.vendor ID, and yeah, query that uses a self-join. So v.vendor ID, and I'm combining again the two columns from the customers table, and I'm saying that as vendor, and then number of properties advertised and number of properties sold. Yeah. So the thing is simply selecting. Wait, if I run this, I have this. So this is this is a list of all customers who have their properties advertised and sold. Yeah. So this is simply the vendors table self-joining itself. Now the vendors table is actually just this column here and these two columns. This column has been used just to show the names. So without this column, the query still works very well. The query still works very well. So I'm selecting the vendor ID, the number of properties advertised, and the number of properties sold here. So now I actually wanted to check if a number of properties advertised, if all the number of properties advertised have been sold. So if they haven't been sold, if I list the number of properties sold is lower than the number of properties advertised, it brings me this now value here. Otherwise, anything else is supposed to bring me that exact value. For example, this vendor here advertised 4 properties and sold all 4. That's why we have this. This vendor advertised 3 properties and sold less than that or even none. That's why we have this now value. So this table is basically self-joining itself. Yeah. The self-join actually happens here. Vendors v left joins vendors ve. We're simply giving it 2 different alias names. Yeah. So that's it about the self-join. The next query that we're going to see is a query that uses Oh, a query that creates a view. Now the views I created in the beginning of as I was creating the database. So I simply took a screenshot of the query because at least I still have to show what I'm trying to do. So let me just show you that. So here is the query. Yeah, here's the query. Creating a view, add total cost as select this yeah, as yeah, we're selecting the advert ID from the adverts table. We're selecting the price per ad occurrence in the newspaper table and the advert occurrence in the adverts table as total price. So we're trying to calculate the total price of a particular advert. So this query here is being used as a view here. So every time we, for example, I shall go back to the console and then try to select the view just to see what's inside the view. Now I'm selecting, select all from the views table, which was add total costs. There it is. So it has simply calculated the total prices for each view, rather for each advert. So if a price changes anywhere, this view, this column here, the specific value has to change with that. So I put this one instead of 4 here. That's why we have all these numbers. But yeah, what really matters is how the view is used. So the next query that we're going to see is the query that uses a view as a relation. As I said, the relation is a view, and this simply means us retrieving it, and that's simply just what we did here. Select all from the add total cost. Remember, this is a view. So when you say the query that uses a view as a relation, it basically gets this. Yeah. So the next query that we're gonna the next query that we're gonna look at is a trigger. Yeah, a trigger. A query that actually creates a trigger. That will be very important in our system. Now, again, I already created this in the beginning, so I'm just gonna throw a screenshot of the code. So here we are creating a trigger. This trigger is gonna come after we set it to the property sort table. We want this that every time we set into the property table, the property sort table, the properties table has a column known as property status whose default is available. Now we want it to change to sort every time that property is added into this property sort table. Now this means that every property, whether it be stored or not, is still going to be in the properties table. The only difference is every property that has been stored will have the property status as stored. Otherwise, anything not with that will have the available. Yeah, available. So if I go to the console, so I go to the console and then is that the console? Oh no, okay. If I go to the console, what's the console? Yeah, so here's the console. So if I go to the console and then I show triggers, I have 3 triggers currently. I'm not sure if you can view exactly what, but the name of the trigger that we just created, that I just showed you right now is the after property sort trigger. So let's just look for that here. After properties trigger. So this is after property advertised, and then sort update, and then after property sort trigger. Here it is. So it is updating properties, set property status, where the property ID is the one that's been updated. And then we're also updating the clients. We're setting the number of properties bought, so we're simply incrementing the number of properties bought. Since a client has obviously bought the property, we're also updating that. So this trigger activates 2 actions, 2 different actions. The first one in the properties table, and the next one in the clients table. So obviously this means if we actually describe the clients table, there's a column here that says number of properties bought. So every time a property has been sold, this table here, this column, this row rather, increments on that specific client who's bought the property. And this comes in handy in several occasions. So that's basically it about the queries that that could be used for showing the expressiveness of for demonstrating and testing the expressiveness of my database system. Every query given in the assignment has worked, and with the scenario, that is, with my scenario, it has worked very, very well. There have been very few errors, which is a good sign. All these triggers mentioned above have their specific purposes. We have the after property added trigger, which simply updates vendors column, or yeah, row rather, setting the number of properties advertised. Every time a vendor advertises a property, the number of properties advertised value increases, and every time a property is sold, that value is the number of properties sold value also increases. Yeah. So thank you very much for watching my screencasts. Hendrik Ventura once again. Thank you.